Okay, let's look at some problems that are maybe a little bit less challenging than the previous lesson. So Matrix, let's read this. A rectangular area is to be enclosed on 3 sides by a fence and an existing hedge, which forms the 4th side. Okay, so what you've got, if you look at this carefully, if we draw a picture here, let's get some nice color. What we have is you've got a hedge here. Okay, a little bit of a hedge. A hedge is like a little plant. It's like little shrubs or something like that. Okay, it's a hedge. You get them. It's a lot of greenery, and it forms like it's like a lot of plants that form like a hedge. And then he wants to get some maybe wire, and he creates his little fence here. Okay, and this is little fencing. So here's a hedge. Okay, and it's made up of like little plants or trees or something like that, and it's dense. Okay, now find the maximum area of this rectangular area here, and its dimensions. That's the length and the breadth. If 100 meters of fencing is available, so this fencing here, of this fence, there's 100 meters available. Okay, now how do we approach that? Okay, typical exam question, have a look. Here's your hedge, okay, that's like plantation, and what we can do is we can call the length y and the breadth x. Now remember, this is fencing that's going there, and inside we can put chickens or cows or whatever they want to do. Okay, but there's a hedge, so it might be like a wall if you like. You could even have a wall there, and then you put the fencing around there. So we can call it a hedge, maybe even a wall. It could be a brick wall, but this is made up of plants. Okay, it's called a hedge. Okay, now what do we do here? Okay, well, we know, if you think about it, okay, we know, if you have a look here, I'm going to do this quickly. What we know, and this is so important, guys, is the fencing is 100 meters. So we can say this x plus the y, the length, plus the breadth is 100. Okay, now what we've got here is we've actually got 2x plus y is equal to 100. Okay, now hold on to that. Now what are they saying? They're saying to you, we want to get the minimum area of this rectangular thing. Now remember, the x and the y can change. Now I'm not going to go into this, but you can get a maximum area, because why maximum? We want to put a lot of animals or things into this thing. Now you could have a little thin strip here. It could be a little strip thing, or you can have a square, or you can have something, but we want to get the maximum area. So how do we get area now? Now area is the length, which is y, times the breadth, which if you think about it is xy. So this is the area. Now they want to maximize, this is important, maximize the area. Now what we've got is an area expression and something relating to the fencing. Now when you differentiate, now this is important, you have got to have an expression with x's in. Okay, now how on earth are we going to do something with this area? Now watch this. This is not too bad. If your area is x times y, okay, can we do anything to get y? Well, look at this. If you take this equation here, you've got 2x plus y is equal to 100. What we could do is say y is 100 minus 2x. So that is very good, because this expression can be substituted into here. Okay, and we will definitely have an expression for area. Area would be x times 100 minus 2x. And that's wonderful, because we can then differentiate that area expression and then put the derivative equals 0 to get a minimum or maximum. Remember, think of a maximum turning point. Okay, at the turning point, the derivative is 0. It's where the derivative is 0. Okay, a minimum turning point is where the derivative is 0. Now hold on to this. So what have we got? So we've got our fencing x plus y is 100, and we've got the area is length times breadth, which is xy. And then we reworked this equation here which gave us y is equal to 100 minus 2x, and we substitute it back into there. Okay, now let's have a look. What can we do? So we've got our area in terms of x is going to be x and 100 minus 2x. Okay, if you go back and check, 100 minus 2x is that. Okay, great. Now, how do we then proceed from here? Well, what I could do is I could go and I could multiply out 100x minus 2x squared. Now look, this expression is actually in its own right a little unhappy parabola. Look at this. It's almost an unhappy parabola, this graph, and it's got a maximum at where the derivative is naught. Now, all you have to do is whenever you want to minimize or maximize, you go like this. You put the derivative, which is 100 minus 4x, you differentiate those, put it equal to naught, and look what happens here. You then bring that across. X is equal to, what's that? Is 25 meters. Okay, so that in terms of your little, there's your hedge, and you've got that there. Your x is 25 and 25. And you can easily work out the y by going 100 minus 2x, which is 100 minus 50, which is 50. Now that's 50. Now that gives you 50, 25, 25 is 100 meters. And for those dimensions, you have a minimum or maximum area. Stay with us on Matrics Uploaded. We'll be back for another example in the section on calculus.